Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of the oblique plane which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So here we have got a 30 degree 60 degree set square which is having 60 millimeter as its longest side. So it is oriented in such a way that its longest side happens to lie in the horizontal plane, and its longest side, it makes an angle of 30 degree with the vertical plane, and the surface of the set square, it makes an angle of 45 degree with respect to the horizontal plane. Now since this set square surface, it makes an angle of 45 degree with respect to the horizontal plane, therefore to begin with we are going to assume that this set square, it is going to lie on the horizontal plane. That is, the first inclination of this particular set square happens to be with respect to horizontal plane. So therefore the top view projections which will be obtained below the XY reference line onto the horizontal plane, they will provide the true shape projections of this set square. That is, first of all we will be drawing the true shape projections of the set square below the XY reference line onto the horizontal plane. And because the longest side of the set square, it happens to lie in the horizontal plane, therefore this set square must be lying onto the horizontal plane to begin with. So we are going to draw the front view projections of the set square as an edge view onto the vertical plane, and these projections will be lying on the XY reference plane. Now we have to decide about the orientation of this set square which is going to have a triangular shape. We can discuss about two orientations for this triangular set square. Now first orientation is this one, which is incorrect. Now why this is incorrect? Because if we have the orientation of the set square like this and we draw the true shape onto the horizontal plane, then either we have to tilt the set square with respect to horizontal plane at an angle of 45 degree in this orientation or in this orientation. So either way, whether we tilt it like this or we tilt it like this with respect to the horizontal plane, so we are going to have the location of this set square onto the horizontal plane. It will be resting on one of its corners over there. Either it will be resting on this corner or it will be resting on this corner. So no way we are going to obtain the longest side of the set square resting into the horizontal plane. So that's why this orientation of the triangular set square seems to be inappropriate. So next we can have the orientation of the set square in this manner. So now we can see that if we draw the set square in this orientation, then the front view of this triangular lamina will be again an edge view, and we can incline this edge view either like this or in this orientation. So if we incline this lamina in this orientation, it will be resting on one of the corners. So once again, we are not going to get one longer edge resting into the horizontal plane. So here we have to draw this triangular lamina onto the horizontal plane in this orientation, and then we have to incline the edge view in this orientation. So the moment we incline the edge view or the front view in this orientation, then we will find that the set square will be inclined with respect to horizontal plane at an angle of 45 degree in such a way that the longer edge of the set square will still be resting onto the ground. So once we draw the top view projections in this orientation and incline the edge view of the set square in this orientation, that is inclined in this way with respect to the horizontal plane at an angle of 45 degree. So this longer edge, it will be still resting on to the horizontal plane, and then we are going to obtain the true length of this longer edge of the 30-60 set square obtained on the horizontal plane, that is in the top view. So after this, we find that the longer edge which is lying in the horizontal plane, it is further inclined at an angle of 30 degree with respect to the vertical plane. So thereafter, we are going to incline this apparent shape of the triangular lamina, which we are going to obtain when the edge view is inclined at an angle of 45 degree with respect to the HP. So into this apparent shape, we are going to get, this will be the apparent shape, this edge will also be apparent shape, but this edge will be the true length over there. So this edge further we are going to incline at an angle of 30 degree to VP. So this way we will be able to obtain the projections of the oblique set square, which happens to be inclined to the horizontal plane to begin with, and then it is further inclined with respect to the vertical plane. Now let us proceed with the construction of the orthographic projections of this triangular lamina. So as we have discussed, first of all, we have to draw the longest edge of this 30-60 set square at an angle of 90 degree with respect to the vertical plane. So once we draw this longer edge, and what are the dimensions of this longer edge? This happens to be 60 millimeter. So we have marked this length of the longest edge of the set square as 60 millimeter. Now since we know that the two edges, the other two edges of this triangular lamina, so they happen to be inclined at an angle of 30 degree and 60 degree over here. So from point C, we are going to draw the second edge of this triangular lamina or the 30-60 set square. So we are going to mark an angle of 30 degree, draw a projection line and extend this projection line. We don't know where the point A will be lying up till now. So what we have to do, we have to extend this projection line to begin with. Then from the point B, now we have to mark an angle of 60 degree and draw another projection line and see to it where this new projection line drawn through the angle of 60 degree from the point B, it intersects with another projection line which we had drawn through the point C inclined at an angle of 30 degree. So the intersection of these two projection lines, they will provide us with the location of the point A in the top view. So this way we are able to obtain the true shape of the 30 degree 60 degree set square onto the horizontal plane, right? So we can call it 30-60 set square, or we can call it a triangular lamina. So we have been able to obtain the true shape of this lamina into the top view projections over here. Now we know that one of the edges, that is the longest edge of this particular lamina, which happens to be BC, so it happens to lie into the horizontal plane. So we cannot incline the edge view like this. So we have to incline the edge view in this orientation. But for that, we need to obtain the edge view of this particular lamina when the lamina happens to rest onto the horizontal plane on the ground. So what we are going to do, we are going to look from the front direction, and in the front view we are going to obtain the edge view of this lamina corresponding to the 3 points A, B and C, and the front view projections will be lying onto the horizontal plane or onto the XY reference line. So from point A, point B and point C, we are going to draw the projectors and extend these projectors till they intersect with the XY reference line over here. So we will be able to obtain the edge view projections of this lamina as we are going to look at this lamina from the front side. So the front view projections, as they are obtained onto the XY reference line, they will provide us with the edge view projections of this lamina onto the vertical plane. So here A dash point is obtained. So here corresponding to points B and C, we are able to obtain the points B dash and C dash over here. Having obtained the front view projections A dash, B dash and C dash, now we know the length of this edge view. So we will be measuring this edge view length, and in the next iteration we are going to incline the edge view in this orientation. Why? Because if we are going to incline this edge view into this orientation, then we will find that the lamina is inclined with respect to the horizontal plane at an angle of 45 degree in such a way that it will be resting on ground on the points B and C, that is corresponding to this edge BC. So this longest edge BC will be still resting onto the ground. So here we can see that B1 dash and C1 dash points, so they are resting onto the ground. So that is why these points, they have been marked onto the front view projections on the XY reference line. And this length, it is equal to the same length which we had obtained in the previous iteration. So we are going to measure this length, and this edge view has been repositioned in such a way that we are going to get point A1 dash on the top side, and B1 dash and C1 dash points, they will be located onto the XY reference line. And the angle of inclination we have marked as 45 degree. Now since this lamina happens to be inclined with respect to the horizontal plane, so the dimensions AC and AB, so both of these dimensions, they will be reduced or foreshortened in the top view projections over here. And dimension BC, since it is lying onto the ground or onto the horizontal plane, so this dimension will still be parallel to the horizontal plane. So there won't be any reduction or foreshortening of the edge BC, B1 and C1 in the top view projection. So now how do we obtain the top view projection over here? So here, using the principle of obtaining the corresponding points in the top view projections, so we will be obtaining the corresponding projections of the top view projection over here. So now from A1 dash, B1 dash and C1 dash, we have drawn these two vertical perpendicular projectors over here. And from the 3 points of the previous view, that is in the plan A, B and C, so we have drawn 3 horizontal lines over there. And these 3 horizontal projector lines, wherever they intersect with the corresponding projector lines which are appearing downwards from these 3 elevation projection points over here, so we'll be able to find points A1, B1 and C1. So let us see, from point A1 dash, we have drawn a vertical projector downwards. Extend this projector downwards till this projector intersects with the horizontal projector which has been drawn through the point A from the previous plan projection view. So this intersection of these two projection lines will provide us with point A1. Similarly, through point B1 dash, draw a vertical projector line downwards and extend it till it intersects with the horizontal projector line which has been extended through the point B over here. Right? Intersection of these two projection lines will provide us with the location of the point B1. Similarly, from C1 dash, we need to drop a perpendicular projector downwards and extend it till it intersects with the horizontal projector line drawn through the point C, that is plan projection point corresponding to the point C. So this intersection of these two projector lines provides us with the location of the point C1. So A1, B1 and C1, these 3 points, they have been located in the top view, and once we join it, so the apparent shape of this inclined lamina with respect to horizontal plane at an angle of 45 has been obtained over here. So the top view projections which are the apparent shape, so these apparent shape projections, they have been obtained. But even in this apparent shape projections, this A1 C1, so this edge, it is the apparent length, A1 B1 edge, it is again the apparent length, but B1 C1 length, So this edge B1 C1, it happens to be true length over here because the edge BC happens to be lying onto the horizontal plane, or it is parallel to the horizontal plane. So this true length has been obtained even in this apparent shape image or projection of this triangular lamina. Now we are provided with the information that the longest side, which is resting in the horizontal plane, it is further making an angle of 30 degree with the vertical plane. So now with respect to vertical plane, we have marked an orientation line or a projection line which happens to be inclined with respect to vertical plane at an angle of 30 degree. Now onto this inclined projection line, we have to reorient this apparent shape of the triangular lamina in such a way that is onto this orientation we should be able to obtain this particular edge, that is B1 C1, alongside this particular inclined projection line, right? So we have to reorient this triangular lamina over here in such a way that we are going to locate edge B1 C1 as B2 C2 over here. So B2 point will be located. We can see over here how do we transfer this figure. So we can inscribe this triangle into this rectangle. So please check. We have inscribed this triangle into this rectangle. And once we know the dimensions of the rectangle, we have drawn the edges of the rectangle over here in such a way that the longer edge will be lying alongside this inclined projection or the orientation line. Now 3 points we need to mark. First point will lie here, second point will be lying here, and the third point will be lying over here. So how do we obtain this point? These 2 points we know, these are the edges of the rectangle onto the base, but this point will be located at a distance of this much. Please check this distance. So only rectilinear distances we are going to measure over here. So this rectilinear distance we will measure, and from this point we'll mark this rectilinear distance. So these 3 points, they have been located corresponding to A1, B1 and C1. So this point name will be A2, this point name will be B2, and this point name will be C2. So we have been able to transfer this triangular lamina or 30-60 set square in such a way that the longer edge, which is a true length and it is lying into the horizontal plane, it is inclined with respect to vertical plane at an angle of 30 degree. Now these are the projections of the oblique lamina which is inclined to both horizontal plane and the vertical plane. So the top view projections, they have been obtained. Now we need to obtain the front view projection. So once again the corresponding projections we need to obtain. So from point A2 we are going to draw a vertical projector in the upward direction and extend this till it intersects with the horizontal projector which is emerging from the point A1 dash. Similarly from point B2 we are going to extend a vertical projector line, extend it upwards till it intersects with the horizontal projector line which has been drawn through the point B1 dash. Finally through the C2 point, again we are going to draw a vertical projector in the upward direction, extend it upwards till it intersects with the horizontal projector line which is emerging from the point C1 dash. So all the 3 points corresponding to the elevation projection of the oblique lamina, they have been obtained. So A2 dash, B2 dash and C2 dash points, they have been obtained. Now we can join A2 dash, B2 dash and C2 dash. So this way the front view of the oblique lamina, the top view of the oblique lamina, so both of these orthographic projections, they have been obtained over here. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how do we obtain the orthographic projections of the oblique 30 degree, 60 degree set square when the lamina happens to be inclined with respect to the horizontal plane at an angle of 45 degree, and the longer edge of the lamina, it happens to be inclined with respect to the vertical plane at an angle of 30 degree. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the planes in the coming lectures. So thank you very much. Thanks a lot.